Hello, everyone. Welcome to the sixth lecture on fundamentals of C++ programming. I'm Murtaza, and today we are going to talk about classes and objects in C++ programming. Okay, let's do a review for the previous lectures. In the previous lectures, we talked about procedural C++ programming. We say that we follow steps and processes, definite processes, where we write header files, source files, declare variables, and then we define them, define functions, and finally we make code. We say that we first write header files and include them in C++ files, and then these files become to object files by the compiler, and then these object files become executable by the linker. We talked about machine code or binary code, mainly 0 and 1, and we talked about compiling and scripting languages. We say that scripting languages do not deal with the operating system directly. However, compiler language such as C++, they directly deal with the memory, low-level memory. And we talked about the building blocks of C++, where we say the code is built with elements and blocks. They have identifiers and attributes. They have the type, and we also talked about two processes in developing codes, the compiling process and linking process, and say that there are errors associated with these two processes, the linker error and the compiler error. We need to solve these errors when we want to run successfully our program. Talked about one definition rule, say that declarations, functions, as well as the classes have to be defined only once, and we have to avoid repeating multiple definitions. And you say there is only one main function for a program, and that function is recognized by the operating system. Talked about declarations, how we declare variables in the header files mainly. And the declarations consist of the identifiers and the data type. And there are conventions and rules where we use them to write the identifiers, and using the building data types, mainly the integer, double, void, char, and bool, we can declare variables in the header file. You say during the declarations, we can also initialize the variables using the safe method and unsafe method. And in the safe method, which we recommend, we mainly initialize variables in a way that the implicit conversion occurs between the data types. We may not have a loss of information. However, in the unsafe method, we may encounter loss of information. We talked about explorations in C++, how we write statements and a way where we do calculations. For example, we may have trigonometric operations, and there we may have operands and operators. The operands are the names, and the operators are the signs and the functionality that we want to apply on the operands. We talked about conditional or selective statements, where we use if clauses, and in there we may have else if statements and also else statements at the end. We talked about loop statements, mainly while and for loops, and there we said we can use continue and breaks. wherever we want to iterate, we want to continue our iterations or want to break the operations, the iterations, in a set of numbers. We talked about functions, how we declare functions, how we define functions. We talked about functions overloading, and also we talked about arrays and vectors. Said arrays are fixed size elements, sets of numbers with the same data type. We, for example, have a set of integers or doubles. We can put them in a single set of array. And we also talked about vectors, and in the vector we say the size of the array is defined during the runtime, and therefore it allows us to have large arrays and that can be defined during the runtime. In the very last lecture, lecture 5, we talked about memory, pointer, reference. I hope you have watched the lectures and have done the exercises. If you still have any issues, problems with the exercise in the lectures, you can ask me directly and I will answer your questions in the Q&A session. In this lecture, we are going to talk about object-oriented programming. So we are done with the procedural C++ programming fundamentals. Now we go to the object-oriented programming, mainly the class. And objects, we'll talk about constructors and destructors in the classes. We will also talk about the inheritance principle in C++. In the next lectures, we are going to talk about polymorphism and abstract classes. We'll talk about error handling in C++, exceptions, how we test a unit of code, and their test cases. We are also going to talk about software development process, mainly how to develop libraries using CMake, and how we write codes in the Git using Git and GitHub. We talk about templates, and we also going to talk about geometric modeling in C++ programming. We will also talk about virtual functions and function objects, and how we do Python binding. It is worth to mention that C++ is an extension of the programming language C, where the classes are added. So classes are fundamentals of object-oriented programming. What is a class? Classes are user-defined types. We had built-in data types where we can create, for example, double integers, but here we can have instance of class the way we want, and it defines a data structure that contains both variables and methods or functions. And after we define a class, we can create instance of a class that has the same attributes. For example, if we have the class book, here book is the name of a class. It's very general, but we may have different types of books, instance of books. For example, history books, engineering books, and other types of books. How we declare a class? First we write the class name after the keyword class and a space. The class name starts with the uppercase character, and then we have a parentheses and access specifiers, where we have 3 types of specifiers: public, private, and protected. The public access specifier allows other functions and classes outside the class scope, they can have access to the data inside the class. However, protected access rights allows only the inherited classes that we may also talk about it later. And the private access specifiers allows us to have access to the data inside the functions, and it protects the other functions outside the scope of the class. And then we may have different members. Members can be variables and functions are called member functions. We may have many access specifiers, different access specifiers simultaneously in a class. And finally, after the parent is closed, we need to have a semicolon. Okay, the question is how we define a class. Well, the class objectives is to define a real object by describing their attributes and their actions. The attributes of a class can be defined by the variables and the actions that are conducted on those attributes are mainly the methods or functions. What are class members? As we say, class members are both variables and functions that are part of a class, and the member functions can have access to all the members inside the function. And the way we access the members within the function is using the dot operator that we will do in examples. What are encapsulation? Well, the data encapsulation is one of the most important principles in object-oriented programming, where the data access is safely encapsulated by the members within the specifiers. As we said, we have three types of specifiers, and the private specifier mainly encapsulates data inside the function, and this data hiding is called encapsulation. Only member functions can operate on that data. Other functions outside the scope of function are called free-floating function, and which are normal functions, and they are not part of the class. So when data is inside the specifier protected or the private, they cannot have access to the data inside a class. The private, as we said earlier, is accessible only by the class member functions, and it is usually the by default access specifier in case we do not have a specific specifier. Public specifiers are accessible from everywhere, wherever a class is visible, and the protected accessible is accessible by the member functions and the derived class functions, which we call them inherited classes. Let's do examples how we declare and define classes and how we can declare members, both variables and functions. We may have header files, for example, the class.hpp. There we include ifstream, we include cmet, and then we use namespace std for making things easier. And then we declare class person, and inside the parentheses we specify the public specifier where we declare family name using the string and then we set the age inside the public, and this is a member function. Inside this member function, we have integer years, and then we have age equals to years. So we already defined the set age member function. The same we set the weight, set family name, and family name is of course a string. And then we set the country. So a person class may have family name, the weight, and the age, as well as the country where he lives. And the location, of course, equals to country. On the other hand, we get the age, we get the weight, and we also get the family name. So we also get the country, with returning the location. We have a specifier private where we have integer age, double weight, string location, and a string family name. This is how we declare a class. As previously, we already declared the class person. Now we did implementation. The class .cpp, and there we include the class HPP River file, include iostream, and we may have one main function. And inside the main function, we create an instance of the person, for example, Ahmed, where using the dot operator, we set the age of Ahmed equals to 25, set his family name to, for example, Rushan, and we also write the weight for 69.5, and we may write the country Afghanistan. And then we can write the cout where the Ahmed age equals to returning the Ahmed age using the get function, and we also return the weight as well as the last name and the location, of course, the country. When we run the code, we find out that Ahmed age equals 25 years old. His weight is 69.5 kilograms, as well as last name is Rushan, and he lives in Afghanistan. So we had the class person, and the class person may have hundreds of instances like Ahmed here. And in the main function, we can create instances of class person. So here, the person is, of course, the user-defined type. Previously, we could write integer, double. Now here we only have here person, and you don't see any double in integer directly here. Okay, let's go for implementation and Visual Studio. First, we create a new project, an empty project, and then we call it class example. Okay, there is already a name, so we just need to change. I can write lecture class. We created the lecture class project. the header file, I write HPP, and for the source file, I write lecture class.cpp, and in the header file, I write include IO string, also include string, because we may have some examples of string, and using the namespace std. Using namespace std, I write a class, kind of say person, for example, and for the class person, then we can write the parentheses here. Public is a specifier, and person here is the name. And class is a keyword for the classes. So for public, suppose we write double weight, or we can write the some very generic family name. So Android. These are, for example, the variables need to be written in the public specifier. We can write some member functions. So these are member variable. And country is also member variable. So suppose we write age. And for the age, we can write string or integer years, and age equals to years, but we do not have age, so I can write another specifier for the age, and also a weight. Now we have 4 variables, and that's enough for this example. And we call another function. We call it setWeight, and in the weight we can write double kilogram, and inside the function we can write weight equals to kilogram. There are 4 variables and 2 functions at the moment. I can write similarly other functions like set family name. And for family name, we can write string name, and here we can say family name equals to name. And for the country, we can also set the country. And of course, country is a name, so it must be string. These are the set functions, and for the return functions or get functions, we can just write the same. Only we need to change this as date, age, and here we say return years. I'll return age, you can say directly. So for the get function, for that we can also write directly the age without any arguments. And for that, we need to write exactly type of the variable we want to return. So we can, for double, the return type is, for the weight, the return type is double, and here we say return weight. We can also write the get family name. And for family, of course, we need to return string. And here we return family name. For a country, we can write get country. And of course, it's also string. And inside the parentheses, we do not need to write anything. And here we say return country. That's all the member functions we need to write for the lecture class HPP. And here we need to include in the source file, we need to include iStream as well as include the header file for our example, and of course lecture class.hpp. We have one main function, and in the main function we can create instances of the class person. So we have example person. In the example, I think it's Ahmed. So we write Ahmed as an example. Can say John, any name you want. Okay. So we can write we can set age for smile, and suppose it's John. So for John, we write, for example, he is 30 years old, and John weighs suppose he weighs 80.5 kilograms, and John lives, sorry, I have to set weight. Okay. I don't know why it's red. Let's see. We have set weight, so it's a bit different. Set weight. Yeah. We can also write the family name for him, and suppose his family name is Jack. I hope it has a family name, not sure. and suppose his country is he lives in UK. Okay, we initialize the parameters for John, which is an instance of person. Now we can return these variables for him. So we can write John is get age. Let's see what we have for the get age. It says return age. Here we see that it is return gets years, and therefore we need to return age. I suppose we return years. See what happens. Okay, we do not have any variable years, so it is get age. First, one thing I forgot was that I had to write John to get access to the age. Okay, now we go to second statement and we call he first he weighs his family name is last sentence for John is country, so we can write he lives and he lives in country whatsoever it is. Of course, he lives in UK, so we can write that here. So we run the code. There are some issues. That's age. Another issue is, yeah, that's right. So now I'll show you the results. The code runs successfully, and now you see that John is 30, he weighs 80.5 kilograms, and he lives sorry, his family name is different. So there is a mistake in the code. I go to the code directly and in the class.cpp, okay, his family name is John Gate family name, and he lives in Gate country. So it's correct. And here we see Gate family name, return family name, Gate country, return country. So they are also right. Set family name as Jack. Okay, here, of course, set country as UK. So now I hope the issue is solved. How the code runs successfully. Again, we can say that John is 30. He weighs 80.5 kilograms, and his family name is Jack. He lives in the UK. This is example for last person, and John is an instance of the class. Next, we go to another example for the class. Okay, let's shorten the previous example by creating multiple objects. First, we include iStream, CMate, and then using namespace std, we define class person. And inside a public, we have a string family name, and we set attributes function that includes multiple objects, integers, strings, and a string. But for the return functions, member functions, we cannot shorten them. We have to return individually each of the member variable. In the private, we include age, country, and after declaring the set attributes, we define the set attributes as void, person, and inside the attributes we define integer as age, string family name, and a string country. And using the this keyword, we can define the age equals to age, family name to family name, and country equals to country. This is how we shorten the long previous example to a bit shorter version of it. Now we go to write the source file where we create multiple objects by including the iStream and the class.hpp using the previous namespace std. In the main function, we, for example, create the person Ismail, which is an instance of the person, and in the Ismail.set attributes, we define age equals to 34, last name equals to Ibrahimi, and country Germany. And easily we can write that Ismail is Ismail.getAge years old in line, as similarly his family name is Ismail.getFamilyName, and he is living in Ismail.country inline. And after running the code successfully, we can find the attributes of Ismail, where he is 34 years old and he lives in Germany, and the family name is Ibrahimi. So we created the class person, and we created multiple instances of that class. Previously was Ahmed, and then we could write multiple objects for the example Ismail. Okay, let's go to the second example. We already created project class example 2. And here we created a header file and a source file. In the header file, we include audio stream. We also include string. And then using the namespace std, we want to shorten, we want to make short statements, therefore we use namespace std, and we make a class called person that should match the example we already covered in the lecture. And here in the class person, we can write identifiers and specifiers. So here, person is identifier or the name of the class. Public is called a specifier. And we have 3 types of the specifiers. For this, we can say for a person has family name. Where it is public, usually everybody knows about it. A person might have country, and for this, we also may have a private part where the specifier is private, and only member functions can have access to these variables. For that, suppose a person has an age and he has unique weight. These are member variables. For member functions, we write in the previous example, we had written 4 functions, member functions for setting these variables. However, to make it shorter, we write set attributes functions, and here we call it integer age, double weight, string name, and string family name, and string country. So here, one function is declared. And for getting or returning these parameters, we can write void or integer for age. We write return age. For weight, we can write double 8 weight. We have 2 other parameters. One is string get country. And another one is the family name. So we write it family name. These are the return functions for these parameters. For the set attributes parameters, we have to define the function as well. It's just declaration, and therefore I make a copy of it. And after the class, I can write the definition. So here I can write the keyword this. Yeah, we call age equals to age, or weight. We call it weight, or family name. Call it family name. And for the country, we call it country. This is how we define the function set attributes with specific parameters that you see here. However, for this, we also need to um, define these attributes, because it's outside the class. We have to specify that this is for person attributes. After this, we go to the C++ file, source file, and we include IO stream, as well as including the class example2 dot HPP, and in the main function we do the implementation. As you know, we have already the class person, and this we can create instances of the class person, as we would easily write instances of double integer, the built-in data types. Now we have user-defined types, which is person. So we can write a person, for example, any name. I can write John. And here we can set attributes of John. So John set attributes, and for his attributes we can write the age. Maybe John is 37 years old and his weight is 86.9 kilograms. His last name is, for example, Jack, and he lives, for instance, in Germany. This is how we initialize the instance of person and John with specific attributes. Furthermore, we can write the return statements, which we say John, for example, John is 8 age, years old. We can write he is um, kilograms. Furthermore, we can write about John, what his family name as and country. We say his family name is Gate, John Gate. Family name. And finally, we can write he lives in of course, he lives in Germany. So we implement and run it. I want to show you the results. The code runs successfully, and you see that John is 37 years old. He is 86.9 kilograms. His family name is Jack, and he lives in Germany. This way, we created a shorter version of this previous example, a bit different one. Maybe it's not a shorter version, but it is a different version using the keyword this. And we have to remember that for attributes outside the class, we need to initiate person here. Okay, we go to the example for constructor and destructor. How we declare these two classes, destructor and constructor, as well as how we define them, how we use them. Let's start this example. We first include in the header file, we include iostream. We also include string in case we need some. For example, we say class name is person. And then in the parentheses, we write the attributes or the members of the class. For public specifier, we consider to make it easier, we write using namespace std, and string family name as before, string country. And then we have private members where we write integer age and double weight. For the public part, we can write constructor and destructor. We said constructor has the same name as the class. Here we have person, therefore we can write person, and then we write the argument types integer age, double weight, string family name, and string country. This is how we declare class, declare a constructor of the class, and then we write some member functions like for the age we write integer get age, and we return age. And for the weight we write get weight, and for that we write return weight. Weight. Okay, let's go for the other two main member functions. Get family name, where we return family name, and for country we can write string get country. We return entry. This is how we write member functions, as well as the constructor and then the destructor for the class person. We also need to declare the instructor here, so we can write tilde person, and then we can write just the declaration of the destructor. A double weight and integer age. Now we go to the definition of the constructor. We say that person is the destructor, and of course it has the same attributes as the class, but now we need to initialize it with the integer age double weight, as well as string family name and string country. And inside the constructor, we can then write, so this is the definition of the constructor. We say that we use this operator here and say age equals to age. This weight equals to weight, and this for family name, we can write the family name, and for the country, we can write country. This is how we define the classes, and also we can write the definition for the destructor, where we say person, and we use tele person, and then we can write that cout object is destroyed after the destructor is called, and this message displays is displayed on the console. Okay, now we are done with the header file. We go to the source file, and here we include iostream. We also include the header file as class x.hpp, and then in the main function we do the implementation. So for the person example, we can say just initialize the person. For example, suppose he is Ali, and Ali will be initialized with some variables. Suppose he is 21 years old. His weight is 56.4 kilograms, and his family name is Behzad, for example, and he lives in Canada. Here, Ali is the instance of class person, and it is initialized with some values. And then we can write the definition for the statements. We say Ali is Ali.get age, and here we can say he is blah blah years old, and then we can say he is Ali gate weight, and here we can say kilogram. So we are writing about his weight, and now we do the last name, say, his last name is Ali. Okay, family name, and then we can say inline, and finally we can say about the country he lives in, and then write get country. So that's all for this example. We write the instance or Ali for the class person, and then we write the statements for this. So we run the code, and now let's show you. I want to show you the result of the code, and you see that Ali is 21 years old. He is 56.4 kilogram. His last name is Behzad, and he lives in Canada. Then after all of this, we say the statement is written, the object is destroyed. So automatically, when the object is destroyed, this message is displayed. That's how the destructor is called. Okay, now let's go to the last example for lecture 6. In this example, we are going to demonstrate the inheritance principle in C++ programming. First, we include IOStream. We include the string as we need to have some strings in our examples, and we also apply std. So using namespace std, we make a class using keyword class for parent, and then we are going to make the parameters and the variables. So for the parent, suppose we have public specifier, and here we may include variables such as a string family name, as parent person has a family name. He may also have country where he lives, and furthermore, we maybe we can put these to the another specifier. We call it protected, because in inheritance we have we can use a specific type of specifier which we call protected beside the parent public and private. In the public part, we can write some member functions and member variables, such as maybe we can put like the address of the person, the weight, and whatsoever. However, in this example, we want to just use two parameters or attributes of the class parent to be inherited for the class San. So in here we only write integer, maybe string gate country, and here we can write return entry. And for the family as well, string get family name, and here we can also write return family name. So these are the functions for member functions for the public parent var. And yes, in the next class, we can say class San, and class San, if you want to do inheritance principle, here we say public public parent, and inside the public parent, we can then write the characteristics of the San. For example, San may have, beside the family name and country name, which he inherits from the parent, he can also have access to, he can also have other attributes, especially for himself. For example, he may have, in the public part, he may have name, and then a San may also have a specific attributes such as name. Let's make set some attributes for the person. Suppose we write function set attributes for him, and we say he has name, and furthermore, he may have country, and beside that, in this, we can say this name equals to name, family name equals to family name, and this country equals to country. One thing we should not forget is that for inheritance, we use only one to call it one colon for the inheritance. We only use one colon. So San inherits properties of the class parent. So here San is a unique class, and he gets some properties of the parent. And now we go to the class CPP, and the class CPP we include iostream. We also included the class It's for HPP, the header file. And in the main function, we can create instance of class parent and son. Suppose we create an instance of son, maybe we write son, for example, John. And John is a son, he has parent, of course, and for him we can say John set attributes for him. We can write his name is John and his family name is, for example, Jack, and he lives in Australia. So this is also a string type of chart type, and we need to write the side quotation. These are the parameters or attributes of the son John. And of course, as you see in the header file, the class son doesn't have any parameter, family name and country name. He has a function, local function, but he doesn't have the parameters. So he inherits these properties from the public parent, the class parent, and therefore can use functions and say he is John get here we can directly write John last name is, so family name of course this get family name is also the member function of the parent, and John can directly get this function. So for the next statement, we can write about country. You say John lives in so write some comments. Here we say John is an instance of the class son. He inherits the properties of his parent whatsoever. And this or the example. This is example for that, and then now we run the code. And now I'm sharing with you the result. As you see, the run code successfully, and now we say John last name is Jack. John lives in Australia. So he inherited the properties of his parent, Jack, who is also living in Australia. I hope this example was clear for you, and you now understand the concept of inheritance. Thank you for watching. I hope to see you in the next Q&A session where we will solve the problems in the exercise. Please don't forget to share this video with your friends. Please subscribe this channel so that we can have a larger impact as well as expand our community. I wish you all the best and see you in the next session.